Proper tooth preparation is a fundamental step in restorative dentistry. Specific considerations arise for different types of restorations. Let's examine the key factors to keep in mind when preparing for all digital cemented prosthetics.
The CAD-CAM optimized preparation has a direct correlation with the scanner's ability to capture the surface accurately, the optimal fit and shape of the restoration, the machine's ability to mill print the desired geometry, the material survival rate in the manufacturing and finishing process, and the long-term clinical success. Let's explore some general preparation principles for the different cemented restorations: crown, inlay, onlay, veneer, and bridge. Incisal, occlusal, facial, axial, and gingival reduction dimensions may vary based on the specific clinical situations and the characteristics of the selected manufacturer's CAD/CAM material. Here's a case by Dr. Guilherme Varela where a subgingival onlay preparation was done. Take a look at the soft internal angles and transitions. Every inlay, onlay, and overlay are unique. As you know, the preparation is adapted to the patient's tooth, decay, and material selection. Therefore, always remember to prepare soft and rounded internal angles and transitions, as this will lead to a successful outcome. When discussing tooth reduction in preparations, minimum thickness of the materials come to the conversation. There are different manufacturing parameters that are tested and validated for each meal and material combination. In the lack of compression, visibility is key. Conventional impression taking depresses the surrounding soft tissue. So let's always remember that optimal preparation is also accompanied with good soft tissue management and moisture control in order to capture all the relevant details with your TRIOS intraoral scanner to send to the dental laboratory or produce your own restorations. Let's briefly touch upon drill compensation. After we have prepared, scanned, and designed our restoration, it is time to produce them. Drill compensation is an added surface that compensates for the size of the burr, ensuring that every restoration will fit.
If a milling machine is used for production, it might be necessary to use the drill compensation function. This compensation adds additional offset to the interface in areas having too high curvatures compared to the radius of the applied drill tool. This ensures that the milling of the interface is possible, which in turn guarantees a better fit to the final manufactured restoration.
Here we can see how the preparation does have a direct impact in how a crown is milled and adapted. We can also take a closer look. Here we can see some radiographical evidence on drill compensation and how it can directly impact the cement gap and fit of the restoration. That is why the preparation geometry for restorations of incisal edges and cusp tips must be rounded and large enough to fit the drill that it will be used in the subtractive manufacturing process. The TRIOS toolkit can be a great ally when it comes to achieve the CAD/CAM optimized preparation. Let's take a tour on some of the tools available in your scanning workflow. But first, we need to ask, why is it important to mark the tooth? The order form is well equipped with all relevant treatment types. Therefore, select the correct treatment for your cemented prosthetic work. After scanning the patient, the software will prompt you to mark the tooth in the scan step. What it will do is optimize the mesh density and give local accuracy to the scanned and a proximal context. This will be applied for single and multiple preparations. So remember, good local accuracy can be achieved by marking the tooth. Let's take a look at this case by Dr. Douglas Watt. In some instances, the dentist might have a specific plan in mind. Plans might change based on the clinical findings, tooth decay, and material considerations. Independently of these findings, the digital tools such as shades, HD photos will help you detect, visualize, and adapt to the situation, achieving superior clinical results. The TRIOS toolkit can be found in the scan steps as well in the Analyze page. When it comes to assess the preparation contours and texture and its final quality, post-process is your best ally. Post-processing is the conversion of acquired streams into the final 3D models. With this view, you will be able to see what the dental laboratory receives from you. Therefore, we highly recommend to assess your preparation after post-processing. From margin line visibility and quality of soft tissue management, to the contours and quality of the actual reduction and neighboring structures, this tool can assist you. If the preparation is not adequate, you can always prepare again and rescan your patient. As mentioned earlier, tooth reduction dimensions may vary based on the specific clinical situation and the characteristics of the selected manufacturer's CAD/CAM material. This can be assessed in the occlusion scan step and in the analyze page while your patient is still on the dental chair. By enabling this tool, you can clearly set the minimum thickness parameters in the distance map on the right-hand side of the screen and assess if your preparation is adequate or not. In the case of requiring more preparation, you can always go back, prepare more on your patient, and rescan the area of interest. This will minimize errors in the occlusal fit and minimum thickness of the materials you have selected and grant you more predictable treatment outcomes. You can clinically visualize and plan the ideal insertion direction based on the tooth preparation and surrounding anatomy. With the use of the tool direction, the software allows for precise adjustments and manipulation of the restoration's position and orientation by rotating the 3D model on screen. You can adjust to your desired orientation and set the direction. Afterwards, a color map will highlight potential undercut areas.
When the lab is designing the crown, insertion direction can have an impact on the final crown seating and interproximal design of contacts. The lab will have a positive and predictable experience if during the scanning step the clinician have assessed the insertion direction and made the necessary adjustments.